We're now going to provide a few more matrices definitions that you need to keep track of and remember. And these relate to determinants. And a determinant is a number that comes from adding the multiplication of various entries. And it's hard to define it any more than that, but it's a single number, and it kind of gives the implication of how big the matrix is and what it's going to take to invert it. So it's a way of determining a single number value of a matrix that can then be used in other calculations. The ways that we find that is by using things called minors and cofactors. So a minor is a matrix made up by ignoring one row and one column of a given matrix. So it's always one row and one column smaller. So if I have an m by n matrix, the minor is an n minus 1 by n minus 1 matrix, and we ignore a given row or column. And so there's several minors that you need to find, but you can find them by specifying which row and which column you want to give out. So this is given by an m, I, j, and we ignore row I and column j. The cofactor of an entry is given by aij is given by minus 1 raised to the I plus j times mij. So the cofactor, you take the minor, and then the minor of the same ij, you add them together, and you multiply that by minus 1, and that gives you your cofactor. And so it's really, really, really nice to use these because they help us break down bigger matrices into smaller matrices so that we can get our answer. The last definition that you need to know is this Cramer's rule, which is a rule that says using determinants and replacing columns in a specific way, and we'll give that way in just a minute, can be used to solve systems of equations or matrices. So we can find an x, a y, and a z by using just determinants and some clever replacing work of the matrices, and we'll get our answer.